Hi everybody, so in this video we're going to continue with Differential Calculus 2 from Chapter 10 and specifically 10.3, the product and quotient rules. So first of all, what is the product rule? It's a rule for differentiation. And basically what it says is that if you have a function, let's say h of x. So h of x is a function in the form of a multiplication of two different functions like f of x times g of x. Then what the product rule says is that the derivative of h of x is equal to f of x times the derivative of g of x plus g of x times the derivative of f of x. Of course, we have different notations for that. For example, here we have it in terms of u and v. So instead of f of x and g of x, you can also find it in terms of u and v. So for example, you can say the same thing and say that the derivative of u times v is equal to u times the derivative of v in terms of x plus v times the derivative of u in terms of x. Very well, so here we are with example 10.7, and it says use a product rule to compute the derivative of the function y equals x squared plus 3x times 2x minus 1. So obviously you guys know how to expand this by multiplying them and then finding the derivative using the power rule. But in this case, they want us to compute the derivative using the product rule. So we can identify this as u and this as v. So recall that the derivative in this case would be equal to u times derivative of v plus v times derivative of u. So this actually simplifies the process, makes it much shorter than expanding and then finding the derivative using the power rule. So let's just do it. So the derivative of y is going to equal u, which is simply going to be x squared plus 3x times the derivative of v, which will be 2, plus v, which is the second factor here, so 2x minus 1, times the derivative of u, which is going to end up, oh, this is 3x here, which is going to end up being 2x plus 3. And then all we have to do is just expand and add terms that are similar. So we're going to get 2x squared plus 6x plus 4x squared plus 6x minus 2x minus 3. And then just add similar terms. So we're going to get 6x squared plus 12x. Minus 2x, I forgot this. So this is going to be 10x. So plus 10x minus 3. So next we'll do example 10.8, and it says given y equals x squared times sine of x, find dy dx. So dy dx would equal x squared times the derivative of sine of x plus sine of x times the derivative of x squared. So notice that this is the same thing, except that I'm using a different notation. So then we were going to get here that this is x squared times the derivative of sine, which is cosine. So x squared times cosine of x plus sine of x times 2x. And normally we like to write this with this in front of the sine expression or cosine or whatever other trigonometric function you might have. So in the end, we can say that the derivative of y is going to be x squared cosine of x plus 2x sine of x. Very well, so next we have example 10.9, and it says find the exact coordinates of any stationary points and any inflection points for the curve y equals x times e to the power of x. Classify any stationary points as maximum, minimum, or neither. Okay, so if we have that y is equal to x times e to the power of x, well then this is obviously u and this is v. And let's recall that the derivative of such functions would be equal to u times the derivative of v plus v times the derivative of u. So in this case, it's going to be x times the derivative of Euler's number, which is just Euler's number, right? E to the x is just e to the x, plus v, which is e to the x again, times the derivative of x, which would just be 1. So in other words, the derivative is equal to x times e to the x plus e to the x. And they say find stationary points. So that means equaling this to 0, as you all know. So if we equal the derivative to 0, we're going to get that x times e to the x plus e to the x is equal to 0. Factor out e to the x. So it's going to be e to the x times x plus 1 is equal to 0. And the only solution here is going to be x equals -1 because there's no way that this can equal 0. Right? This never touches the x-axis. E to the x never touches the x-axis, so it cannot equal 0. Therefore, there's only one stationary point for this graph or for this function, and it's going to be when x is equal to -1. Now we're going to see if it's a minimum or a maximum, and that depends on the concavity. And we can do that by finding the second derivative. So notice that the second derivative is going to be equal to, we're going to have to do the derivative of this part plus the derivative of this part, right? So here we have to apply the product rule. And notice that this is the same function that we had at the beginning. So we're just going to rewrite the first derivative. So it's just going to be x times e to the x plus e to the x. And then the derivative of e to the x is just e to the x, so plus e to the x. And with this, what happens when we plug -1? What are we going to get? So if we plug in -1, this is going to equal, it's going to be equal to -1, yeah. So this is going to be -1 times e to the -1 plus e to the -1 plus e to the -1. And this is going to be -1 over e plus 1 over e plus 1 over e. And we can cancel this out with that. So the answer is 1 over e, and this is just going to be positive. Therefore, the concavity is upward. So this is definitely a minimum. Okay, so next, they want us to see if there are any points of inflection. So let's recall that we said that this is the second derivative. Notice we can simplify this into x times e to the x plus 2 times e to the x. So if we want to find points of inflection, we have to equal this to 0 and then solve. So then here again, we have to factor out e to the x, and we're going to get e to the x times x plus 2 equals 0. Therefore, the solution is x equals -2. So this is probably a point of inflection. But let's just verify that to see if there's a change in concavity. So how do we do that? Well, we do that with a table of values. Remember that we can put -2 here in the center and then test for something to the right of -2 and for something to the left of -2. So to the left of -2, we can test a number or a value such as -3, and to the right of -2, we can test a value such as -1. So we already did -1, and we recall that when we plugged in -1, we got 1 over e, which is greater than 0. Therefore, the concavity here is positive or upward. So logically, we should get a negative concavity to the left of -2. So let's see if that is true. So if we have that we plug in -3 into the second derivative, it's going to be e to the power of -3 times -3 plus 2, and then this is going to equal 1 over e to the 3 times negative 1, or negative 1 over e to the third. So that means that we get negative 1 over e to the 3, which is obviously less than 0. Therefore, the concavity is downward before negative 2. So this is definitely an inflection point. So we found the solutions, right? We found that there's a minimum. So we say there's a minimum when x equals negative 1. And if we want to find the y-coordinate, because they're asking for exact coordinates, so we have to find the coordinate. For that, we have to plug it into the original function, right? So y of negative 1 is going to equal 2 negative 1 times e to the minus 1, which is going to be negative 1 over e. Okay, so that means that the minimum, the coordinate for the minimum, is going to be negative 1 comma minus 1 over e. And then the inflection point, so we have an inflection when x is equal to negative 2. So we would proceed in the same manner. We would have to plug in negative 2 in the original function. So what is y of negative 2? It's simply going to be negative 2 times e to the minus 2. Therefore, negative 2 over e squared. And then that means that the inflection point will be minus 2, comma, negative 2 over e squared. And then we're going to show the verification of this on the graphing calculator. Okay, so here we are with the graphing calculator, and we're going to plot x times e to the x. So notice that here is the graph. So we're going to look for the minimum. Remember, we can do that with the second function on the trace key, which is calculate. And then number 3 for minimum. And then remember that here they always ask for a left bound and a right bound. So we know it's negative 1, but we just want to verify it. So let's move a little bit to the left of negative 1. Hit enter. Okay, now the right bound. So we got to move to the right of negative 1. And there we are. Hit enter. Guess, yes, thank you. And there it is at negative 1, comma, negative 0.367879. Now remember that we said that the minimum occurs at negative 1, comma, negative 1 over Euler's number. And this here, these decimals are obviously equal to 1, negative 1 over Euler's number. Okay, so next we're going to move this to the left a little bit, and we're going to visually see the change in concavity of the graph at x equals negative 2. Now notice that this would be the point of inflection right here. You can barely see it, but the concavity here is downward, right? You can see that the curve has a slight downward concavity. Then after this point, like a bent wire, it starts going in the opposite direction, right? So it has a concavity that is upward. So this is definitely a point of inflection. Okay, so in the next slide, you're going to find the quotient rule. So the quotient rule is the rule you would apply for the derivatives of expressions such as u divided by v. So if we have a function y, which is equal to u divided by v, then the derivative of y would equal the denominator v times the derivative of the numerator minus the numerator times the derivative of the denominator divided by the denominator squared. So notice that here you have the same rule, but in terms of g of x and f of x. Then it's going to be g of x, the denominator, times the derivative of f of x, the numerator, minus f of x times the derivative of g of x over g of x squared. Okay, so here we are with example 10.10. And it says, given y is equal to x plus 3 over 2x minus 1, find the derivative of y. So all we have to do here is apply the quotient rule. So let's recall that if we have f of x over g of x, right, if y is equal to this, then the derivative of y is equal to the denominator times the derivative of the numerator minus numerator times the derivative of the denominator over the denominator squared. Some people like to remember this also as low d high minus high d low over low squared. And this part up here, low d high minus high d low, reminds me of an old song, so it's easy for me to remember. Low d high minus high d low.
Heidi, 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 ho! Heidi, 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 ho! Eddie, 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 Eddie! Eddie, 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 Eddie! Whoa! Heidi, 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 ho! Heidi, 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 ho!
Okay, so then that means that we're going to do low, which is 2x minus 1 times the derivative of the numerator, which is just 1, minus high, which is the numerator, so x plus 3 times the derivative of the denominator, and the derivative of 2x minus 1 is obviously 2, and this divided by 2x minus 1 squared. So normally you're going to want to expand the numerator, but leave the denominator in this form where it's squared. Just leave it like that. So we're going to get here that it's going to be 2x minus 1 minus 2x minus 6, right? You have to be careful with this negative because it turns all the other signs opposite after the negative, right? So this over 2x minus 1 squared. Very well, so one final step where we cancel this out and add -1 and -6, so we get -7 over 2x minus 1 squared. Very well, so next is example 10.11, and it says, given y is equal to 1 over 2x minus 3, find the derivative by using A, the quotient rule, and B, the chain rule. So the quotient rule again, recall, it's simply going to be that if we have that y is equal to f of x over g of x, then the derivative of y will be g of x times the derivative of f of x minus f of x derivative of g of x over g of x squared. Okay, so this is the rule, and all we have to do is plug in and substitute. So we would say then that the derivative of y would be low g of x, so that's just going to be 2x minus 3 times the derivative of the top, which is 0 because the derivative of any constant is 0, minus 1 times the derivative of the bottom, which is going to be 2, and this over 2x minus 3 squared. And then notice that this is going to end up being -2 over 2x minus 3 squared. Why? Well, because this cancels out, and -1 times 2 is -2. Okay, so for part B, they want us to do the same, but using the chain rule. So remember that 1 over 2x minus 3, we can rewrite that as 2x minus 3 to the power of -1. So this would be equal then to, well, the derivative of this, I should say, right? The derivative of this, let's use proper notation. So if this is y, then the derivative of y is going to be -1, right? The derivative of the outside, -1 times, leave the inside alone, 2x minus 3 to the power of -2 times the derivative of the inside, which is 2. And then we're going to end up with the same expression, -2 over 2x minus 3 squared. So now we are on example 10.12, which will be the last one on this video. So it says, for each function, find its derivative by using 1, the quotient rule, and 2, another method. So any method we wish. Okay, so for letter A, we have that f of x is equal to 3x minus 2 over 2x minus 5. So that implies that the derivative of f of x is going to be 2x minus 5 times 3 minus 3x minus 2, 3x minus 2 times 2 over 2x minus 5 squared. And then expand the top and simplify, so we're going to get that the derivative of f of x is equal to 6x minus 15, and then here we have to be careful with this negative, minus 6x plus 4. And here we go, this over 2x minus 5 squared. And finally, this is going to cancel out here. So we're going to get negative 11 over 2x minus 5 squared. Okay, so next we're going to do it with another method. So this was method 1. Let's say this was method 1. And now we're going to do it with method 2. So the easiest way, I believe, is by doing this. So we can rewrite f of x as 3x minus 2 times 2x minus 5 to the power of negative 1. So notice that here we're going to have to use two rules. We're going to have to use the product rule, and then when we do the derivative of this part, we're going to have to use the chain rule. So remember that the product rule is that if y is equal to u times v, then the derivative of y would be u times derivative of v plus v derivative of u. And then if we have the chain rule, like if we have f of g of x, right? The derivative of this is going to be derivative of the outside without changing g of x times, right? So let's say that the derivative of this, just to be formal. So the derivative of this is going to be the derivative of the outside without changing the inside times the derivative of the inside function. So we have to apply both these rules here. Okay, so for the product rule, we would say u stays the same. So 3x minus 2 stays the same, but we have to multiply it by the derivative of this, for which we have to apply the chain rule. So it would be negative 1 times 2x minus 5, don't change the inside, to the power of negative 2 times the derivative of the inside, which is 2. And then plus this v, which is going to be 2x minus 5 to the negative 1 times the derivative of u, which is going to be 3. So let's rewrite this, and we're going to get a pretty long expression here. So this is going to be, notice that if I multiply this times this, I'm going to get negative 2, and then negative 2 I can multiply by that. So I'm going to get negative 6x, and then negative 2 times negative 2 is 4, so plus 4 over 2x minus 5 squared. And this plus 3 over 2x minus 5, right? Okay, but we're not done, because now we have to add these two expressions, which means that we will have to multiply this by 2x minus 5 as well as the numerator, 2x minus 5. Okay, so I'm going to erase a little bit, and we're going to continue with this on the right-hand side. And we're going to get that minus 6x plus 4 over 2x minus 5 squared plus, and now we can multiply. So we're going to get 6 6x uh, minus 15. 6x minus 15, and this over 2x minus 5 squared. So now we can add these fractions, and what are we going to get? Well, if we add everything, we just get the same denominator, right? So it's going to be 2x minus 5 squared, and then on top, this and this will cancel out, and then 4 minus 15 is going to be negative 11. So we arrive at the same result, but notice that this method, by using the product rule and the chain rule, it's much more complicated than just using the quotient rule. Okay then, so for part B, they want us to find the derivative of g of x. So g of x is equal to 5x minus 1 over 3x squared. So remember that the derivative of g of x is going to be low d high minus high d low. So that's going to be 3x squared times the derivative of the top, which is going to be 5, minus the numerator, 5x minus 1, times the derivative of the denominator, which is 6x. And then this over 3x squared squared. Now all we have to do is just expand and simplify. So in this case, we don't have two terms, so it's okay to expand this. So we're going to get that the derivative of g of x is going to equal 15x squared. And then here we have to be careful with the negative, right? So it's going to be minus 30x squared plus 6x. And all of this over 9x to the 4. And then we can simplify this because we have similar terms. So we're going to get minus 15x squared plus 6x divided by 9x to the 4. But we're not done because this can be simplified. Notice that we can factor out 3 and x and then cancel out. So let's write this as 3x times negative 5x plus 2 divided by, and this we can split into 3x times 3x cubed. And if we cancel this out, we arrive to the answer, which is going to be minus 5x plus 2 divided by 3x cubed. So this was method number 1 using the quotient rule. So another method. So what would be another method for g of x? All right, since g of x is equal to 5x minus 1 divided by 3x squared, I can separate this into two separate terms, namely 5x over 3x squared minus 1 over 3x squared. And then we can cancel out this x and cancel out one of these x's, and then just rewrite this as g of x is equal to 5/3 times x to the minus 1 minus 1/3 times x to the minus 2. So we can now use the power rule for this, right? So the derivative will equal to negative 5/3 times x to the minus 2 plus, because I'm going to bring this to multiply, right? So negative 2 times negative 1 would be plus. So plus 2/3 times x to the negative 3. Okay, so notice that you might not know, but these two expressions are equal. I'm going to verify that. Notice that I can rewrite this as minus 5 over 3x squared plus 2 over 3x cubed. And then if I want to add these terms, these fractions, I need the same denominator. So I would get that by multiplying this by x and multiplying this by x. Therefore, I'm going to get minus 5x plus 2 over 3x cubed.